Chapter 5, Example 5. A cereal manufacturer has a machine that fills the boxes. Boxes are labeled 16 ounces, so the company wants to have that much cereal in each box. But since no packaging process is perfect, there will be minor variations. If the machine is set at exactly 16 ounces, and the normal model applies, or at least the distribution is roughly symmetric, then about half the boxes will be underweight, making consumers unhappy and exposing the company to bad publicity and possibly lawsuits. To prevent underweight boxes, the manufacturer has set the mean a little higher than 16 ounces. Based on their experience with the packaging machine, the company believes that the amount of cereal in the box fits a normal model with a standard deviation of 0.2 ounces. The manufacturer decides to use the machine to put an average of 16.3 ounces in each box. What fraction of boxes will still be underweight? So this is a pretty straightforward problem. We just want to calculate a z-score and then look in our table and find the probability that we would get a value at that z-score or lower. Check the conditions. The company believes a normal model fits the distribution of cereal box weights, so it is okay to proceed. So we're good. Just state that. Always check the condition and state it. I don't know that you checked it if you don't write a statement out saying that it's been done. Now let's sketch the situation. Cereal box weights. I have my curve there, and I've set up for number line on the bottom. My mean is 16.3 ounces. I'm 0.2 ounces for standard deviation. So 16.1 on the left, 16.5 on the right. Again, one standard deviation away is the inflection point on the curve. We'll go another standard deviation away. Now, when you make the second standard deviation, you want to measure it. It should be the same distance from the mean as first standard deviation is. So if your inflection point is an inch away from the mean, the second standard deviation should be an inch away from the first. The third standard deviation should be an inch from the second. 15.9, 16.7. Third standard deviations, I'm going 0.2 lower on the left, 0.2 higher on the right. So 15.7 and 16.9. We're interested in boxes that are underweight. Underweight means 16.0 ounces or below. 16.0 is in between 15.9, so I'm going to put a vertical line there. It's 16.0 ounces, and I want to shade to the left. So I'm looking at everything to the left of that area. To do that, we need to find the z-score for 16, and then simply look at our table. So I'm going to have 16 minus 16.3 over 0.2 equals negative 1.5. I have a z-score of negative 1.5. I'm going to go look at my table now and find out what probability that provides us with. The probability that z is less than negative 1.5 is 0.0668. We just look in the table like we did on the previous problem. You look for negative 1.5 on the left. Up top, you look for 0.00. Go down that column, and there you go. Now, we write the normal model out in a specific way. And this is important because sometimes you might not show the work, especially when we start looking with technology in the future. And if you don't write the formula out, you haven't stated you're using the normal model, especially if you forget that sentence. So we want to write it out because when you write out the normal model, it tells us the mean and standard deviation in it. You write it as n for normal model, parentheses, mean, comma, standard deviation. So when I write out my conclusion here, I'm going to write it in that form. According to the normal model, n parentheses 16.3, comma 0.2, about 6.7% of all cereal boxes would have weights below 16.0 ounces. So working for that company, you have to decide, is that significant? Is that too much? Are we going to get sued? The company president vetoes that plan, saying the company should give away less free cereal, not more. Her goal is to set the machine no higher than 16.2 ounces, and still have only 4% underweight boxes. The only way to accomplish this is to reduce the standard deviation. What standard deviation must the company achieve, and what does it mean about the machine? So now we're going to use a z-score here again, and we need to think about it. The standard deviation is now unknown. We don't know what it is. We know we want 16 ounces, and we want our mean to be 16.2. So on top of my standard deviation formula, I'm going to have 16 minus 16.2 over the unknown standard deviation equals z. I don't know what that z is either, so I have two unknowns right now. Can we find one of those values out easily? Now, fortunately, we can, because 4% is the area under the curve. So 4% is 0.04. We go to the table like on the previous example. We look in the center of the table for the closest we can get to 0.04. And then we look at the margins on the left and above, and that gives us a negative 1.75. So we have 16 minus the mean, 16.2, over the standard deviation, equals negative 1.75. We're going to multiply the standard deviation to the other side, do the subtraction there, 16 minus 16.2. We get negative 0.2 equals negative 1.75 standard deviations. Find the standard deviation, divide by negative 1.75. And then we get 0.114 equals the standard deviation. So our model would be n 16.2, 0.114. So the normal model with a mean of 16.2 and a standard deviation of 0.114. According to the normal model, having no more than 4% of cereal boxes underweight with a mean of 16.2 ounces would require a standard deviation of 0.114 ounces. The company's lawyers say that 6.7% is too high. They insist that no more than 4% of boxes can be underweight, so the company needs to set the machine to put a little more cereal in each box. What mean do they need? So now the standard deviation stays the same. We want to see what the mean would have to change to. We already know 4% would be a z-score of negative 1.75. So we'll proceed with that. In this case, we know what the standard deviation is, so we'll sketch the curve out. So we'll kind of sketch the curve out here in standard deviations. We have the mean in the middle. We don't know what that is, but we know we're going to be one standard deviation at the inflection point, two standard deviations, three, so on. So we know what the curve's going to look like. We're going to be way over here. 4% is going to be between 3 standard deviations and 2 standard deviations away. So I'm looking for that spot to the left, kind of shaded in so we can just get an idea. A big advantage of sketching this curve is it helps you know, are you looking to the left or the right? If I was looking to the right, I can't just use that value I get from the table. I have to do something with it. In an earlier example, we had everything to the right. We had 10% to the right. So in the table, we had to look at 90%. So if I was shaded to the right, whatever probability I get from the table, I'd have to subtract from 1 to find the true value. Okay, so we know the values here. We're going to use our formula. 4% is 0.04, which gives us a z-score of negative 1.75. So 16 minus x bar over 0.2 equals negative 1.75. Multiplied by 0.2. We're just going to do the algebra here. We get 16 minus x bar equals negative 0.35. I'm going to add the 16 to the other side, which would give me negative 16.35. But because the x bar is negative, cancel those out. So I get x bar equals 16.35. So our model is n 16.35, 0.2, mean of 16.35, standard deviation of 0.2. According to the normal model, a mean of 16.35 ounces of cereal would allow us to produce less than 4% of all boxes of cereal that are underweight.